Hello everyone, so I'm back again with another video. My name is Antoinette C. Panoy from BSECE 3A, and for today I'm going to discuss another topic in my subject ECE 23 for my performance task number 2. Now, that will be about multi-level 2B1Q. So of course, my learning objective for this one is to of course define to you what 2B1Q is and why it's under multi-level and to show you the advantages and the disadvantages of 2B1Q as well as giving you the example in order to at least understand more about this line coding scheme that I'm referring to. Now we'll go ahead, which starts with line coding scheme. So as what I'm showing here that I've highlighted what's to be specific I'm going to talk about. So line coding does have unipolar, polar, bipolar, and multi-level, multi-transition as well. So we have, I'm showing here the multi-level, which is just my focus. And under multi-level, the 2B1Q is can be found. Now I have here definition of multi-level line coding scheme 2B1Q. For the multi-level, it's an increase in number of bit sense, or we can also define that as increase in speed transition. So encoding M data, well, M data is the smallest information. So it's like the beats like that. So for the elements into a pattern of n signals, so the n signals is the smallest data signals. So that's what we call that one. And yeah, anyway, for the 2B1Q, it's two binary, one quaternary. So that's what how we are going to read that one. Another definition here is multi-level signaling is often used as a means of compressing the bandwidth required to transmit data at a given bit rate. All right, so let me show you the advantages of 2B1Q. So it helps to increase the number of bits per baud is desired in data communication. It can send more than one data with signal and hence save bandwidth required. Required average BW equals N over 4. There is no redundant signals patterns in this technique. It is also used in digital subscriber line or DSL to provide a high-speed internet connection. Typical codes balance voltage leads to lesser baseline wandering. So that is more about deeper information of 2B1Q. At least if you know this, guys, just let me know. Thank you. Yeah, we'll go ahead with the disadvantages. Now, it is a complex receiver has to distinguish for different thresholds as 2B1Q uses four different levels of signals. No self-synchronization for long pattern of similar double beats. Long sequences of zeros or 0, 1 will have constant DC output. Hence, spectrum creates very low frequencies which present problem in certain systems. All right, so this is a quick, not a quick, maybe creative way at least to explain to you what's or how to understand about 2B1Q. So M is the length of binary pattern, B is the binary data, N is the length of a signal pattern, L is the number of levels. So letter uses for number of levels will be number 2 will be the letter B, number 3 will be the letter T, and number 4 will be the letter Q. So Q is the four levels that we are saying to you guys. So 2B1Q, 2 will be the length of binary pattern, B will be the binary data, 1 will be the length of signal pattern, 4 will be Q will be the four levels. So the table here at the right side is like two data elements for one signal element. So that is how we understand this table here. Now we have a table that will help us to at least understand the examples later. So anyway, next bits will be used as 0, 0, 1, 0, 0, 0, 1, 1, 0, and 1, 1. And then next level for the positive and negative with a positive 1, negative 1, and then so on and so forth. So we'll just need to follow. And let me just explain to you the one by then later. Right? Now I have here an example that where the table that I've shown to you a while ago will be used. Now I have the example for 0, 0, 1, 1, 1, 0, 1, 1, 0, and 0, 1. So the next bit for this first table or column here is 0, 0. So for the 0, 0, since we don't have any previous level yet, so we'll use the number 1, positive 1. So we're going to write a line here. Now for 1, 1, since the previous level is positive, so we'll just follow negative 3. All right, you see this table here? All right, that's how we follow that. So we'll go down and write another line. Now, since the previous level for 0, 1 is negative, so we'll go ahead and follow negative 3. So we'll just another extended line here. Now for 1, 0, since the previous level is negative, we'll follow this. So it will be positive ones. We'll go up, put a line here. And for 0, 1, that will be previous level is positive. So we'll go ahead with positive 3. We'll wrote and then this one. So that's how it looks like. So that's how we are going to write the 2B1Q in a table for a line coding scheme. All right, now we go ahead with another example. I have here 1, 1, 0, 0, 1, 1, 0, 0, 1, 0, and 1, 1. So this is like longer than what we have in the previous example. Now, anyway, we'll have here the 1, 1. We'll start with, of course, we don't have any previous level yet, so we'll follow 1, 1. That will be negative 3. All right, now we'll follow negative 3 will be negative. Since for the 0, 0, previous level is negative, so we'll follow negative 1. We'll go up, we'll write a line here. Now for 1, 1, since the previous level is still negative, and we'll follow this one, so we'll go up, positive 3. Now for 0, 0, since the previous level is positive, so we'll use this as positive 1, but we'll go down since the 1 is here. So for 1, 0, is that previous level is still positive, so we'll just follow this negative 1. Still will go down, like we're going to write a line here. For the last one, we have 1, 1. And yes, since the previous level is negative, so we'll follow negative 3 here. We'll go up and that's it. So this is the line coding look like for the 2B1Q. Now, I hope you have learned from me, guys. So let me just give you a quick wrap up for the summary of what I have discussed. So again, how do you read a 2B1Q? That's 2 binary, 1 quaternary, because it's a line code under multi-level. So what's multi-level again? It's an increase in number of bits sent. It's like an increase of speed transition. Encoding M data. M data is the smallest part of information and of elements into a pattern of the N signals. So the N signals is the smallest part of signals. And I hope you were just going to at least look back or back read into the slides that I've shown to you in order for you to at least create your own line coding for 2B1Q as well. Well, I hope you have enjoyed watching and see you in my next